other options, so if there's a way to algebraically simplify it, that can be beneficial. But is there a way to simplify this? No. If there's just one term on the bottom, we can divide, but there's more than one, so we can't. So we have to do quotient rule. So quotient rule is low, so the bottom, d high. What is the derivative of the top? 0. Minus high, so the top, d low, derivative of the bottom? Over low squared. All right, 0 times anything is 0, so that all drops out. Minus 1 times 2x would just be a negative 2x over the x squared plus 1 squared. And that is all we can do on this one. Let's do another quotient rule. Is this one all right? Okay. So I'm just trying to throw all the different ways I might ask for a derivative up here. You know, this one I did d sub x. This one I said find z prime, which is the same thing as dz dt. So just all these ways that I might ask for a derivative, just so you're used to it. So the derivative of this. Again, we have to do quotient rule. So quotient rule is low, so the bottom. D high, derivative of the top. Negative 3d squared. Minus high, so the top. D low, derivative of the bottom. Over low squared. We do need to clean this up as much as we can, so let's distribute this negative 3t squared. So we get negative 3t squared minus 3t to the 6th. For this, can I distribute my negative and my 4t cubed? So it's minus 4t to the 3rd plus 4t to the 6th. Over, you could FOIL out the denominator, but I'm not going to. It's not going to help at all. Alright, so now we just combine like terms. Negative 3t to the 6th and 4t to the 6th is just a t to the 6th. I have a negative 4t cubed and a negative 3t squared over the denominator. Let's look at find the equation of the tangent line. So we've done equations of tangent lines before. We know we need a point and a slope. How do you find the slope of this tangent line? Oh, come on. Well, if we had 2 points, it would work. But in general, slope of a tangent line, that's the derivative. So we have to find our derivative. Okay, so my function is e to the x over 1 plus x squared. So we have to do the quotient rule. So low, so the bottom is 1 plus x squared. D high, what is the derivative of e to the x? E to the x. Minus high, so the top is just e to the x. D low, derivative of the bottom? 2x. over low squared. If we distribute, we get e to the x plus x squared e to the x minus 2x e to the x. Okay, so my slope, that's like my formula for slope. The point I'm looking at, my x is 1. So if I plug in a 1 for all my x's, we get e plus 1 squared times e to the first is just e, minus 2 times 1 times e is 2e, over 1 plus 1, so 2 squared. And what's that turn into? E plus e is 2e, minus 2e is 0. Over 4.
That's what 2 squared was.
Yeah. 0 over 4 is 0. Okay, so now I have a point, I have a slope, so I can plug into y equals mx plus b. So my y is 1/2 e equals my slope is 0 times x plus b. So my equation is just y equals 0x, so that just goes away, plus 1/2 e, so it's just y equals 1/2 e. We just get a horizontal line right there. Any questions for me? So the next table is just kind of a summary of all the different things we've done so far with derivatives. Tells us, the derivative of a constant is 0. If you have x to a power comes down, subtract 1. Derivative of e to the x is e to the x. If you have coefficients, they just stay. If you have things added, subtracted, multiplied, divided, tells us those rules. So that's just our summary, nothing new, just everything we've done up to this point. So, at this point, you guys have that worksheet. So this would be the time that if you had any questions on that worksheet, you ask those. We will grade that and turn it in at the end of class today. Then you have time to start these book problems. You will have some class time tomorrow as well if we need it. And then we're kind of reevaluate tomorrow and see where